What you see over here is the world's very first and only vehicle that can be driven by the blind. Called the Blind Driver Challenge, in 2007, the National Federation of the Blind, NFB, gave a challenge to the research universities and different research laboratories about who can develop a car that can be driven by a blind. We thought that we can take up this challenge because we already had an autonomous vehicle. It turns out that we were really wrong. What NFB really wanted was not a vehicle that can drive a blind person around, but they wanted a vehicle where a blind person can actually make active decisions and drive the vehicle. So we had to throw everything out the window and start from scratch. So with a very dedicated team of brilliant undergraduate students and graduate students at Robotics and Mechanisms Laboratory and brilliant engineers from Torque and NFB, we worked together to develop this vehicle. And we're planning to do the first public demonstration at the Daytona International Speedway on January 29th, and we're working very hard to make that happen.
So at Torque Technologies, we develop off-the-shelf products so that we can enable researchers to do research in unmanned vehicles and autonomous systems. So here today, what we have with the Brian vehicle in the Robotics and Mechanisms Lab is we've outfitted this with a couple extra devices. First thing we have here on the front are two laser scanners. So these are scanning laser rangefinders that sweep out in front of the vehicle and detect obstacles in the road. We also have, along with those, looking from the inside of the vehicle, a set of cameras mounted up here in the corners. Those cameras are for looking and determining where the road is. So they're looking at things like pavement versus grass, lane lines, and trying to detect where the road is. All that information is being transmitted throughout the vehicle to the back. It's combined with one more laser scanner here underneath the rear bumper to allow for reverse operation, as well as a GPS unit and an antenna on the top of the car. All of that data comes in to the back, to the trunk here, where essentially we have the brain of the system, or at least the part of the brain that's responsible for perception, for perceiving the environment and making sense of it. So all that data comes in here. We create a picture essentially of the environment, and we take that and send that data back up to the driver's seat, where the non-visual interfaces take that information and convey it to the driver.
Today I'm going to show you guys the interfaces that we use for the blind driver vehicle. If you guys come inside and take a look, we have a set of gloves. These are called the Drive Grip gloves. And the way that these work is they have vibrating motors on the tops of each of your four fingers. You can see them 1, 2, 3, and 4. And the way that these work is when the car plots a path around the road and any obstacles that are in front of it, it will relay the steering information to you through these gloves. So when you have a desired steering angle, the vibrations will move across your fingers to help you turn the wheel to the right angle. So say this is your right hand glove right here. You wear this on your right hand like so. And the more to the right you need to turn, the more the vibrations will move across your fingers. So if you need to make a slight right hand turn, you'll feel your pointer finger vibrate. If you need to make a harder right hand turn, you'll feel your pinky finger vibrate. And the closer that you get to the right spot, the vibrations will move across your fingers until you feel no vibrations at all, and that's how you know that you have the right steering wheel angle. We also have here the seat, which is called Speed Strip. Now, Speed Strip is used to communicate speed information the same way that the Drive Grip gloves communicate steering information. And the way that it does that is it works very similar actually to the Drive Grip gloves. There's actually rows of motors that go down the seat, down your legs, and then another set of motors that go up your back. Now, the faster that you need to go, the more the vibrations will move down your legs. And the slower that you need to go, or the more that you need to brake, the more the vibrations will move up your back. So it's a very effective way of communicating speed and steering controls using simple vibrations. And they're actually been proven to work very well on the road so far with all of our testing, so we're very excited, and we look forward to showing them off at Daytona.